Okay, we'll start here. We are continuing our talk on object-oriented programming. So on Wednesday, we introduced objects and classes. So I guess specifically we introduced classes. We showed functions that can interact with classes. We showed classes are mutable, how to define classes, and things like that. And today we are going to continue to talk about classes, and today's topic is very important. It's methods. This is probably the reason why people would use classes in the first place, is that you can create what are known as methods. And pretty much all of my content is coming straight from chapter 17 from our textbook, Think Python. And I recommend that you go through it again or read through it. So basically, a method is a function. Okay, so it's just like many other functions in Python, and except the method is associated. Okay, this function. So whenever you hear the word method, you can just think in your head function, but it's a function that's associated with a particular class. Okay, and the key difference between just general functions and methods are that for a method, the function is defined inside the class. Okay, it's you define the method inside the class, and then when you call a method, the syntax for calling the method is different from a regular old function. So let's revisit the time class object that we created on Wednesday, and this is just showing what we did. And so what we did was we created a class called time, and we didn't really put anything inside of it, but this does create a class called time, and then we defined a function called print time that takes a time object, okay, and then it prints it out using the format operator in Python. Okay, along with kind of the attributes that are associated with the time object. Okay, and in order to use it, we had to define an object. Here we call start, which is going to be a time class object, and then we assign the attribute the value 9, 45, and 0 to the attributes hour, minute, second, and then when I call print time on start, it prints it out in the format specified. So this is kind of where what we did on Wednesday, and I hope all of this looks familiar and feels okay. And what we're going to do today is we are going to expand on that by kind of turning this print time into a method. Okay, and so to make a method, all we have to do is we're just going to move the function definition. So we're going to move print time, which is just defined in the top level structure main, double under main. Here we're going to put it inside the class definition. Okay, and so here inside class time, I'm going to define the function print time, and it's the exact definition I had before. Okay, and so now that we've redefined this class with the method inside, we can call the method. Sorry, let me. My kids are being a little noisy. Okay, so now that we've defined it inside here, we can call the method. And so I have to, in order to use this, I'm going to have to recreate the start object as a time class object, okay? Because this start object is created using this time definition, and when you update the class definition, those changes don't apply retroactively. So I have to redefine it here. So I'm going to create start here, and then again I assign 945.0 to the attributes of start, and then to call the method, I can call it like this. So one way is I take the class definition, capital T time, and I call the method time.printtime on the object start. Okay. This is uncommon. People don't normally do this. Okay. The more common way is to call the method directly from the object itself using dot notation. So you would call start, okay, which is the object we've defined, and we would call start dot print time, okay. And when you do this, notice the parentheses here are empty, even though inside the definition we said print time time. Inside here there's an argument, okay, and then we need that argument, right, to get time hour, time minute, and time second. We need that argument. When you call a method using dot notation, what happens is the object itself gets passed in as the very first object of the method. Okay, so there's no need, or actually you shouldn't type in the object itself. Okay, because it is understood that this is the first object. So this is effectively calling print time with start inside as the argument being passed in. Okay, and so it's going to work here. Does that kind of make sense? So when you call it with dot notation, the object gets passed in as the first argument. Okay, and so when this happens, okay, the object is known as the subject of the method. Okay, it's the subject of the method, and the subject always gets passed to the method as the first argument. All right, hang on a second. Okay, so by convention, the first argument of a method is going to be called self. Okay, so when you do this, it's called self. It's not a requirement. Obviously, when we define the time here, the first argument of the method is time. Okay, but almost always you will always see it written as self. Okay, so as you read other people's Python code, as you read textbooks, as you read the documentation, even in the documentation, the first argument is called self. But if you use something other than self, like time, it's not going to throw an error, but people will be confused when they try to read your code. And so it's important that you kind of follow the conventions, right? These are kind of almost like social expectations of how we write Python, okay? And the idea is, when you call a method on an object with dot notation, you're applying the function to itself, okay? So so in this case, we'll rewrite our time class as follows, and I'm going to add another method here, and this is going to be, we're going to add time to int on self, okay? And what this will do, this is something that maybe I introduced at the very last couple minutes of class on Wednesday, is that we're going to take the time which stores the time as hour, minute, and second. And what we're going to do is we're going to convert it into the number of seconds from basically midnight, okay? So we're going to take the hour, multiply it by 60, and add the minute, okay? So if it's 2:30, we're going to say that's 150 minutes, okay? And then we take the number of minutes. 150 minutes times 60 is basically 9,000 minutes, and then we add the number of seconds. So if it says it's 2 hours, 30 minutes, and 7 seconds, when you convert time to an integer, it's going to basically return 9,007 seconds. Okay. All right. So again, we have to redefine the object of class. So we're going to redefine start. I assign 9, 45, and 0 to each of these attributes: start.hour, start.minute, start.second. And then I can call this start.printtime is going to be 9:45:0, which if I convert to minutes and seconds, this is 540 minutes, 585 minutes. Multiply that by 60. I don't know what that is. That's going to be, I guess this, okay, 35,100 seconds, okay? So I can do start.time to int. And again, notice here in the method call, these are blank, despite in the self is always kind of being passed here. Okay, so self is always gets passed, but it always gets passed, I guess, without you having to type it in there explicitly. It's always the first argument there. Okay. So we have this function, time to int, which takes the time and converts it to integers. We're going to need a helper function called integer to time. So it's going to, what int to time will do is it's going to take an integer number of seconds, and it's going to create a time object out of it. Okay. I cannot define this as a method inside a class because what it takes on, the object that it takes on is the number of seconds, and there would be which is an integer, and so I don't have a kind of a place to invoke it. Okay, but what this will do is it does modular division, stores the number of minutes and the number of seconds, and then it does modular division on the number of minutes into the number of hours and the number of minutes. Okay, and this basically defines the three attributes: the hour, minute, and second of our time object, and it's going to return time here. Okay, so now that I've done that, I'm going to add another method here. Okay, this method is going to be increment. All right, and so if you remember from Wednesday's lecture, we created a function called increment, but this time it's now going to be a method. And so here, the increment is going to take on two arguments, okay, self and how much time to increment it by. So we're going to take the number of seconds, and what we will do is we're going to do seconds, and we're going to increment the seconds by using by incrementing the seconds with, we're going to take self and we're going to convert it to the number of seconds, okay, and then we add that to this quantity seconds, and then we're going to convert this back into a time object. Okay, and so notice here I am not modifying any of the attributes of time. Okay, I am returning an entirely new time object. So int to time creates a new time class object and returns that, right? It creates time as a new time object and returns that thing. So here I don't modify any of the things. I'm just returning a new thing. So here I redefine start with this new class definition. And then I can print this out. And I can say increment it by 1,337 seconds. Okay. And that basically adds 22 minutes and 17 seconds here. Okay. And this is what it does. Okay. So notice I had to capture or save. So I'm going to say do start.increment, and I'm going to save this as an object called end, and I can say end.printtime. So end is a new time object with this class definition, and it's going to have the printtime method, and so I can print it out, and it will look like this. All right, is this all okay? Give me a green check if you're following along, and if you feel okay with how we are defining classes, defining methods and invoking methods, kind of using the self notation. Okay. I guess I should give you the first quiz answer, and okay. All right. Don't answer the quiz right now, because I think the answer is C, but I should double check that. Okay, I think the first quiz answer is C, and then but I should double check. Okay, yeah, first quiz answer I'll say is C. Okay, but I'll double check before class ends. Okay, so here we are. Okay. All right, so sometimes you'll run into errors, and so here's an example. Let's say I do end is equal to start.increment, and we're going to do 1337 460. Okay, and so here it says increment takes 2 positional arguments, but 3 were given. Okay, and that feels a little confusing, because if you look at the function increment, it looks like we're passing 2. It looks like we're passing 1337 and 460. Okay, but what's happening is that, remember, start, this the object that we invoked the method upon. Okay, this object always gets passed as the first argument. Okay, there's always a first argument here, self, and it's getting passed as self, and then it's also passing 1337 460. So there really are 3 arguments being passed. Self, the subject of the method, is always going to be the first argument there. Okay. Okay. So you can also define methods inside a class, and those methods can be functions that take on other objects and work with them, right? So what we're going to do is we're going to create a method called isAfter, and that's going to check if one time takes place after another time. Okay, this function is going to take 2 time class objects and compare them, and I'm going to add this method to the end of our definition. All right, and because we were expecting the argument that's being passed to isAfter to be another time class object, we can invoke the methods, the time methods of the object. Okay, and when you do something like this, okay, by convention, you know, the first parameter of the method is always going to be self, and then if you're passing another object to it, the parameter name for the other object is going to be called other. So you're going to have a self and you're going to have an other. And again, this is the convention when you have a method that takes in 2 arguments. All right, and so I think this barely fits in here, but here it is. Okay, we're going to define a function called isAfter, and it takes self in as the first argument, and then the other argument, or the other parameter being passed, is other. Okay, and all we do is we just invoke time to int, okay, which is a method here. Okay, we invoke time to int on the self object. Okay, and this is going to give us the time of this current object. And then we want to know, is it greater than the integer value, integer representation of the other time? So the other object is also a time class object, and it's going to have this method. So we can do this. So it's going to take our current value and it's going to convert it to an integer. It's going to take the other value, convert it to an integer, and then it's going to return just the result of this greater than comparison. So if this is bigger than this number, it's going to return true. If this number is smaller than this number, it's going to return false, right? So it's just going to return true if self is a bigger number than other, which makes sense in the context of this because the question is it after? Is after. So let's just demonstrate this. Again, I redefine my start time using the new definition of the class. I'm going to create another time object using the new definition of class using end. Okay, so we're going to call start.increment and we call end, and this creates this time, and then we can ask end is after start, and this returns true because what it does is it converts this number into an integer, it converts this into an integer, and this number is bigger than this number, and therefore this is true. And when you read it like this, it almost feels like English, right? It feels end is after start. Yes, that's true. Okay. Start is after end. False. Okay. And I think this is one of the reasons why Python is very popular in terms of just coding up quick scripts. Prototyping something very quickly. It's very easy to go through and read code, okay? Especially when you are, especially if you follow the conventions of naming functions that return Boolean values as almost like a question, okay? So is after, it's almost like a yes or no question, and it reads this way, right? Obviously, there's no rule that says you have to name it this way, right? And if you did something confusing, like you said, is before, it's not going to throw an error, but it's going to throw, it's not going to throw a syntactical error, but it's going to make semantic confusion. People are going to be confused trying to read your code, and it's going to be frustrating because ideally, you want to write your code and choose variable names and method names and things like that in a way that is easy to understand and easy to read, okay? Obviously, you should document and add comments to your code whenever necessary, but if you're smart about the names that you choose for your methods and the names you choose for your variables, okay, and it's a difficult thing to do well every single time, but if you do it well, your code is going to be easy to read. All right, so one thing we've been having to do is we've been having to define or assign all of these attributes every single time I invoke, create a new definition or new object with the new class, updated class definition, right? Every time I update the time class definition, I've had to create a new thing, which is fine, but the annoying part is that I've had to define or assign these attributes every single time. I've always had to say 9, the start.hour is 9, start.minute is 45, start.second is 0, okay? What we can do is we can use the init method, okay? Init stands for initialization, okay? And we might call this double under init, okay? All of the special methods get a double underscore in the front and the after, okay? And this kind of indicates to the reader that this is a special Python method, okay? And this is going to this method gets invoked anytime we create a new object of the class, okay? So anytime we create a new object of the class, so every time I call start on time, it's going to invoke the init method. Okay, and so what we do is we're going to use this method, the initialization method, to assign all the values to attributes that are going to be used in the class. So the hour, the minute, and the second attributes that are used in the class, we're going to assign all of them during the init method. Okay, and by convention, the parameters of the init method should have the same names as the attributes. So this is what it's going to look like. Okay, so the init method gets defined right here at the beginning of the time. I mean, the order in which you define these things don't matter, but in general, we would call the init method at the beginning of the class definition. And so here we're going to define init as self, okay, and then the again, self is always the first argument, okay, and then we're going to have 3 parameters, and this is going to be hour, minute, second, and we can give it default values. So we can say hour, minute, and second are all zeros if no values are passed, then it will put zeros in all of these things, and these will also be positional. Hour, we're expecting hour followed by minute followed by second. Okay, and then we assign all of the attributes. Okay, so I'm going to do self.hour is going to be take on the value hour. Self.minute is minute. Self.second is second. Okay, so we assign all of the attributes inside the init method, right? And this way, I don't have to, going back, I don't have to do this start.hour, start.minute, start.second every single time after I create a new thing. Okay, this will happen when we create the new class, the new object, right? So here, creating new time class objects is much easier and much nicer now, right? So I can call midnight, define a new time class object called midnight, and we're going to just call time on this, and this creates the midnight, and it assigns 0 to the hour, minute, and second because those are the default values. And then I could say midnight.print time, and it comes back 000. Here I can say, let's make a new time, and we're going to call time on 9. Okay, we're going to pass 9 to the class definition of time, and so this, again, what's happening is that 9 gets passed in as the hour argument. Okay, self is always the first argument. Okay, and so so when we invoke and when we say let's create a new time class object, okay, we're invoking init, and that value 9 will get passed in what appears to be the second argument, hour, okay, because self is always the first. Okay, so we're going to get this, and it's going to pass 9 in as the hour, and then if I call print time on this, it's going to say 900. Okay, yeah, so that's just what I said. Here I can do, again, using kind of positional arguments, this is going to go in as the hour, this will go in as the minute, and if I had another comma, that would go in as the seconds. So here I've got 9:45, and this creates the time 9:45. Okay, so we have a time object, a new time is 9:45 here. Still good? Are we okay with using the init method? So this is, I think, a much more elegant and nicer way of assigning attributes at the creation of the object, rather than having to, before we just created a blank. We had when we talked about classes last week, define multiple constructors. What do you mean by multiple constructors?
Well, like in Java, you can make like constructors that take different arguments. And I understand in Python there are optional arguments. But what if you wanted to take an argument that was like a completely different object type and like synthesize objects from like very different things?
Maybe. You're allowed to make your init definition as complicated as you want to do, right? So if you want to be able to accept in different argument types and have some kind of dispatch system that says like check to see if hour is a list, and then you'll assign attributes in one way, and then or check to see if hour is a different thing, and then you assign attributes in another way. That's allowed. Okay, you can. So here it's just some my init method is very simple. I just take the argument or parameter names and I just assign them to the attributes of self. Okay, but this is basically a function, right? It's just a function that just has this special name init, and which just means it gets called whenever you create a new thing. So you can make this function as complicated as you want, right? You can have if and else that says if hour looks like this, do this. If hour looks like this, do something else, right? So if hour comes in as an English word 3, then do something with it so it becomes a number and assign it or something like that. I don't know if that's the question you're asking, or did you have a different question there?
No, I think that answered my question.
Okay,
Thank
yes.
you.
So you can make this, it's a function, you can make it as complex as you want. Okay, and here's the other important special method. Okay, and this is double under string. Okay, double under str. Okay, and basically, when you call print on an object, what Python is going to do is it's going to invoke the string method, this double under string method. Okay, and so far what we've been doing is we've been calling take the object new time dot print time. Okay, we've been saying this and to get it to look like this. Okay, that's what we've been doing. We've been doing new time dot print time. But to kind of make it a little bit better is what I'm going to do is I'm going to replace print time, get rid of print time, and I'm going to create the string method. Okay, the key difference here is that the string method will not call print. Okay, it's not going to call print, but it's going to return a string object. So let me go back to my class definition here. So right now, print time, it takes the string and it uses the format operator, which will basically fill in these values, hour, minute, second, into this format here, and then it calls print, right? So when we call print time, it takes this string, it fills in the blanks with the attributes of the class, and then it prints it out. Okay, what we're going to do here is we're not going to call print, but we're going to use return, okay? Because here it should return a string. So rather than calling print time, I got rid of that method completely. So print time no longer exists, and I've got this double under string method. Okay, so double under string, you invoke it upon self. Okay, and here you say return, and what it's going to return is it's going to return a string. It's going to return a string where these blanks, the format operator blanks, have been filled in with the attributes hour, minute, and second. Okay, and this will get invoked anytime we call print. All right, so here I create a new time using our new time class definition. And so we got time 9:45, okay? And I call print new time, and then and it looks like this, okay? Because this is the string that it returns, and it prints it out, okay? So this is, I think this is a little bit nicer, okay? Rather than having to keep having things called this way, new underscore time dot print time or whatever it is, okay? Calling this specific method print underscore time, we can call the regular traditional print function onto our time object, and Python knows to invoke this double under string method to get back the string that it wants, and it's going to print this out. Okay, and so so Python has this, I think, a really elegant what we call a data model in terms of having these the ability to kind of create class definitions that work well. Okay, work nicely with others. Right, so here we have this. Okay, there's even more stuff you can do. Okay, there's a whole bunch of double under methods. Okay, and maybe I didn't include the link, but whoops. In chapter 17, make sure you you read up on this, and let's see. For more details, there's under the data model, you have basically all of the special kind of double under methods here. So you got double under init, double under delete, and things like this. Okay, and so these are all things that get called by certain functions, and you can read up on them. Okay, so so here there's one called doubleunderadd. Okay, and this is going to get invoked anytime you use the plus operator. Okay, you use the plus operator, and it's going to invoke addition here. And so what we can do is we can take 2 times here, and so a plus operator requires the object itself plus another number to add to it. So we're going to say, let's take 2 time objects. We're going to, if we did 1 time plus another time, let's convert those both to I'm sorry, there's not a plus here. This is a typo. It should just say seconds is equal to, not plus equals. Seconds equals self.time to int and other.time to int. Okay, and it's going to return seconds after we converted it back. Okay, so I put that right here. So this inside the class definition, there's no plus here. Plus equals, it's just equals. Okay, so we're going to call underadd, double underadd will be self other, and it's going to convert the self time to int. It's going to take the other object, convert it to an int, and it's going to return the integer to time result of the seconds. Okay, so it's going to return a new time here. So let me just show you what happens. Okay, so here we create a time 9:45, another time 1:35, and then we can say start plus duration, and this plus operator is going to invoke the add, and it takes start and it adds duration to it, and it returns the time. Okay, so that's neat, right? I think this is pretty cool that we're able to create basically methods inside our function that that allow us to interact or allow us to kind of be used in a fairly, I think, user-friendly way, right? This plus operator, people understand that, and there's kind of an intuitive sense when we're trying to work with the time object here. Okay. Here is what we can do is we can further make things more complicated. Okay, but it's rather elegant. Okay, so this is known as type-based dispatch. Okay, and what we can do is we can say, you know what, sometimes I want to take 2 times and add them together, right? Like I want to take, we're starting at 9:45, let's add an hour 35 to it. When is it going to end, right? Or we might say, you know what if I just want to add an integer value to it, right? It's 9:45. Let's add 120 seconds. Okay, 120 seconds, then it should return and say it's going to be 9:47. So how should that be? Okay, well, what we can do is we can have 2 add methods. We can have add time and increment. Okay, and based on what gets passed in the plus operator, right? So underscore double under add gets invoked whenever we have the plus operator. Okay, we can say, we can check what kind of class other is, right? So we're going to say if is instance, we're going to say if If the other is a time object, okay, and so isInstance is going to check if this is an instance of the time class, okay. So we're going to say isInstance other time, then we're going to use the add time method, okay. The add time method is basically what we had on the previous definition, okay. And then if it's not a time object, then we're going to assume it's an integer thing. So then we're going to say use the increment method, okay? And again, the increment takes the number of seconds and it increments the self. So this is actually something we had defined before, but that's what we'll have, okay? So we're going to say if it's a time object, use the add time method. Otherwise, use the increment method, because these are both kind of addition operators here. Okay, and this and Python will look at what objects get passed in as other. Okay, and it will dispatch either the add time method or the increment method. Okay, when you call the plus operator. So here's the full definition. Okay, just so that it runs in the code, and so we'll go ahead. So I've got start, I've got duration, and I can do start plus duration, and it adds them together because they're both time objects. Here I've got start, and I added an integer to it, 1337, which is, I guess, 22 minutes and 17 seconds, okay? And so 9:45 plus 22 minutes and 17 seconds will return back a new time of 10:07:17. Okay, and so we can give it flexibility using the plus operator, right? And so Python has really nice flexibility with the plus operator. This allows us to do things like, hey, I've got two lists, and we're going to do the plus operator, and it combines them into a longer list, right? I've got two strings, and I use the plus operator, and it combines them into a longer string. The plus operator, basically the string object class and the list object class have their own doubleunderadd methods that get invoked anytime we use the plus operator. Is this not cool? I think it's so cool. All right. So one thing though is if you try to do an integer plus a start, right? This is a time object, and you try to do an integer and you try to do this, it doesn't work, okay? Because 1337 is an integer, and there's no the doubleunderadd method in the integer class definition doesn't include an option to add time, okay? So it doesn't know what to do. So what you can do is there's something known as radd, okay, right side add, okay, the doubleunderadd, and basically we can define this, and we're going to say self other, and what it's going to do is it's going to return, and so this will get invoked anytime if it recognizes that it's coming after the plus operator, if it recognizes that it's being on the right-hand side of the addition operator, then it's going to say this is the self and this is the other. So then, so it's going to call self is going to be start, the other is going to be 1337, and it's going to invoke this, run self doubleunderadd here, okay? And so this is the class definition is getting bigger and bigger. Luckily, it still fits on one screen, and so now I can do this. I can still do start plus duration. I can do start plus 1337, and now I can do 1337 plus start, and this does not cause an error because it's invoking the right-hand side add. Okay, because we've defined doubleunderadd, we can now use the class objects as this time class objects in functions that use addition, such as sum. Okay, so sum is a polymorphic function, meaning that it's going to be able to handle different types. And so I didn't we didn't redefine a new version of sum. This is just the same old sum that has always existed, but sum takes uses the doubleunderadd method here, and so when we invoke sum, it's going to work. Okay, so here I've got I'm defining 3 times 120, 140, 130. Okay, and then I create a list of T1, T2, T3, and I say sum up the things in the list. Okay, and when I do that, it works. Okay, so I say total is the sum of all of this. This is going to be a new time class object. I say print on this, and it returns all of this. Okay. I wish we were in live because I feel like you guys would be super impressed. But right now, that awe and amazement is lost on Zoom here. But but this is I think this is I think it's so cool. I think it's so cool. Just how Python's handling of objects and methods and all sorts of cool stuff that you can do. It's truly elegant, truly truly great. Okay. All right. If you have a plus b and a has add defined and b has radd defined. Oh, see now you're. I'm trying to think. I want to say it's going to use the a side first. It's going to give preference to add over radd. That's a good question. Let's see. Add versus radd. Let's do this. And addition between classes. Let's just see what it has to say, right? So this, 2 different classes, and I want to define them, and both have add and rad. radd is only called if the left object does not have an add method. Yeah, so it's going to invoke the add method first, and then and that's how it's going to work. So radd, it gets second priority to add. So add gets, if it can run the add, it's going to run it. And if it says, well, I can't do the add, then it's going to search the right-hand side object for the radd. Okay, let's see. All right, so it's recommended that, so technically, you can add attributes to objects at any time, right? So that's what we were doing in the beginning. We were defining start as an empty time class object, and then we added the hour, the minute, and the second. And you can do that. That's legal. That's not going to cause errors, but it could cause problems later down the road because it's going to be confusing. So it's recommended that you initialize all of the object attributes inside the init method. Okay. And then as far as debugging goes, what you can do is you can call vars on an object, and it's going to print out kind of as a dictionary a list of all the attributes. So if I say vars on start, it's going to say, okay, these are the attributes you have, hour, minute, second, and these are the values it takes. And this is going to be useful when it comes to debugging time. Okay, that's it for today. I don't know. I think I've said it so many times already, but the way Python handles the methods is pretty cool, and I hope you are impressed by this. Second quiz answer I think is A as an apple. Let me stop my share for a second. Okay, and I will just double check. I'll just double check that I'm not telling you lies here. So don't, oh my gosh, I'm the worst. Okay, what did I say? I said C and A, or were those what I said for for the quiz answers? Okay, let me make sure that that the quiz will match that. Okay, so it will say C and A. C and A. Those are going to be the quiz answers if you take the quiz. It should work. C and A. Okay, that's it. That's all I've got for you guys today. I will release a homework, another homework assignment, and that's it. Have a good weekend, and we'll see you guys on Monday.